I'd like to welcome Jakob up on stage. Jakob Svenningsson is going to talk about this very topic for the next 15 minutes. Stage is yours. Welcome.
My name is Jakob Svenningsson. I work as a software engineer in the NSO core team, where I've been working for roughly 2 years now. And I'm here today to talk to you a little bit about what you as a service developer needs to think about when developing services for NSO 6.x. This session is mainly going to be like a live coding session. We're going to have a look at an example service that I have written. And this service, it works well on older versions of NSO when it's run sequentially, but it's not very well suited to run on NSO 6.x. And we'll talk more about that later. But before we go into the demo, I'm going to just go through a little bit, just a few slides with some background information that I think is important to be aware of before we jump into the terminal and the demo. Okay, so let's see. Next. Cool, it works as expected. Okay, so the new big thing in NSO 6.0 is the new concurrency model. And this, it's important to be aware of the new concurrency model when we're developing services, because it has some important implications that we need to think about. Okay, now I'm about to, sorry. All right, so NSO 6.x uses an optimistic concurrency model where a lot more code, including user service code, is run in parallel by default. Previous versions of NSO used a more pessimistic model where a lot more code, again including user service code, was run sequentially. So this is the first thing that we need to be mindful about when developing services for NSO 6.x, and that's that service code might, services might run in parallel, and our services need to be able to handle this. Okay, moving on to the next thing that we need to be mindful about, and that is that services might conflict. So NSO is a transactional system, and running multiple transactions concurrently must leave the database in the same state as would have been obtained if the transactions were run sequentially. This is the isolation property, or the I in what's known as the ACID properties. And for NSO to fulfill the isolation property, it has to record all of the reads made by a transaction, and if it detects a read-write conflict, the transaction has to be rejected. In NSO, a transaction in NSO can be divided into different phases, and depending on what phase of the transaction the conflicts occur, the transaction will either be aborted or automatically retried. Service code runs in what we call the transformation phase, and if there is a conflict in your service code, this will trigger an automatic retry, which means that your service code might run multiple times during a single create if a conflict occurs in your service code. And again, your service code needs to be able to handle this. Okay, so I'm forgetting that I have this in my hand. I'm trying to change slide on my computer. Sorry. Okay, so we have concluded that services might run in parallel, and service code might run multiple times in the case of a conflict. And our services need to be equipped to handle this. And to be able to handle concurrent execution, we need to make sure that all data accesses done in our service code is thread safe. And to handle service retries, we need to make sure that our service code is idempotent. And a function is idempotent if it can be applied or executed multiple times with the same input parameters without the final result changing beyond the first invocation. Right, okay, let's see. Okay, so now we're going to talk about another crucial part of service design in NSO 6.x, and it's that, I mean, it's important to try to design your services in a way to avoid conflict from occurring in the first place. This is not always possible, but it should always be something that we strive for. And so why is it important to avoid conflicts? Well, if your service is constantly conflicting with instances belonging to the same service, or maybe instances belonging to another service, then NSO will have a hard time scheduling and running your service concurrently, and will fall back on sequential execution. And this is not something that is desirable, because it has a negative impact on throughput. So to avoid service conflicts, it's important that you try to avoid writing services that read and write data that is shared with other services, or that is shared with either services belonging to the same, or instances belonging to the same service, or instances belonging to other services. And exclusively reading data is not a problem. In order for a read-write conflict to occur, there has to be both read and writes to the same shared data. And now I realized that I forgot I had planned to explain what a read-write conflict is, and I forgot to do that earlier, and then I'm just going to do that right now really, really quickly. So read-write conflicts occur when if you have a transaction A that writes, that reads a value X, but before it commits, another transaction B writes a new value to X. And in this case, transaction A has to be rejected because the red value X is no longer valid. Okay, I think, again, same mistake, sorry for that. Right, that was actually everything that I wanted to say before we head over to the terminal. Well, there was actually one thing that I wanted to mention before that. I mean, the focus on this demo is not going to be to, or the purpose of the demo is not to, show you the optimal ways, or maybe the best practices of doing things. The focus is more going to be on highlighting some maybe you could say some anti-patterns that you should be aware of and try to avoid. Okay, let's see. Nice. Let's see. Can you see? Yes, we're up and running. Nice. Okay, so the service that we are going to have a look at, it's called a NetSim service. And a NetSim service does two things primarily. One, it configures a netconf device on the devices subtree in NSO. And two, it deploys the configured netconf device as a NetSim device. And then it contains some logic to automatically assign a unique port to each device that it deploys. So we can start out with going into config mode, and I'm just going to try to create an instance of this service. It's called NetSim service, and it only expects a single input argument, the device name. So the device name and the name of the service is the same, and that is everything. And then if we go and try to commit this, we'll see that things go just fine. But we're getting an alarm which says assigning to self is not thread safe. So this is a little bit of a spoiler to one of the issues with the service, and this is an issue that NSO is smart enough to warn us about. But let's just pretend that we didn't see that for now, and we're going to come back to this a little bit later. And let's continue with just having a look at the service instance that we just created. So let's see, netsim service, dev1. Then we can check exactly what happened. Oops. Like that, and we can see that we indeed created a device that is called dev0. It has an address, it has a port, it has a bunch of other stuff that we're not going to go through. But we can also verify that we also created a netsim device, and that this netsim device is up and running. Let's see, we can try to connect towards it. And it's up and running. We're getting back true, so things are working as expected. Whew. Okay, so let's go out from the shell and let's have a look at a little bit of code. So we're going to start with packages, netsim service, source, young. We're going to have a look at the young module of the service. And the young module is very simple. It contains very, very few things. We have a container that is called netsim, and inside we have a list called service, which is our service point. And as I said before, it only expects a single argument, the device name, and nothing more than that. And then we have another interesting thing up here. We have an operational leaf called port offset that is of type unsigned integer, and this leaf, it's what our instances of our netsim service is going to use to calculate a unique port for the netconf device that it configures and deploys. So the next thing that we're going to do is that we're going to head over to our Python callback module. And this one is slightly more complicated than the YAG module that we just had a look at, but please bear with me. It's not as bad as it looks like, I promise. So the first thing that is interesting to have a look at is that we have defined a couple of global variables up here with some different port bases. And these variables are, so basically the way that we're going to calculate the unique port is that we're going to add a port offset to a port base, and in this way, and that's the way that we are calculating the ports, right? Let's continue and let's have a look at our service callbacks. So we are implementing two callbacks, the pre-modification callback and the create callback, and we'll start having a look at the create callback first. Oh, no, the pre-modification callback, sorry. And we only want to execute this code if the pre-modification callback is triggered by a create. That's why we're having this first line here. And the second thing that we are doing is that we are reading and writing our port offset. So in this get an increment port offset, what we do is that we read the current port offset, and then we write back the port offset +1. And then we return the port offset that we just read. And this will be the port offset that this instance is going to use to calculate the port number for the device that it configures. And we assign we assign the port offset to a global variable or global class variable called self.portOffset. And the reason why we do this is because we need to access this value a little bit further down inside of our create callback down here. And the reason why we want to read and write the port offset in the pre-modification callback is because we want this change to be done outside of the fastmap algorithm. We don't want the incrementation of the port offset to be rolled back if the service is deleted or undeployed. So that's why we're doing it up here. Okay, so let's move on with the create callback. So the things that we do here is that we pull out the device name from the service input parameters. And then we just sleep for a very short random time. And why do we do this? I just want to increase the probability for an error to occur, so don't have to think too much about this. And then down here, what we do is that we are creating a local variable by assigning the global variable self.port offsets, and then we reset the global variable because we don't need it anymore. Okay, so now we have our device name and our port offsets. So now we are ready to configure the device on the device's subtree, which we do in the apply device config function. And in here, we apply a template that does the actual configuration. Exactly how that is done is not very interesting or relevant to the demo, so we're not going to have a look at it. The only thing that is interesting to know is that the way that we assign the port here is by taking our base port, and then we add the offsets that we read earlier. And once we have configured the device under the device's subtree, we can continue to do the actual deployment of the NetSim device. So that's what we're doing down here. And the deployment can be divided into 2 steps. First, we create the NetSim device, and then we start the NetSim device. And we create it down here in this function. And with NCS NetSim, if you want to create a device with a specific port, you can set a couple of environment variables, exactly the way that I'm doing right here. So so we're setting the environment variables to, we take our port bases and then we add our port offsets. And then down here, we are issuing a shell command, NCS NetSim, create device, and we create the device of type. I have generated a very simple netconf that is called just device. It's not very interesting how it looks like. It's just a very basic device. And then we specify the output directory where we want to save our NetSim device. Nice. Okay, so the last thing that we do is that we invoke start NetSim device, and basically we just trigger and we execute another shell command, NCS NetSim start, and that's it. That's everything that the service does. So let's head over to our terminal again, and let's try to run this. And yes, okay, before we run it, I'm just going to quickly go through. I have prepared a little script that we're going to use to create instances of this service concurrently. And we're just going to wait. And so basically this script, it accepts a single argument, which is the number of devices that we want to create, or the number of instances we want to create, sorry. And the only thing that I really wanted to go through is a little bit how we actually create the service, the service down here. So we're iterating, we define a loop, and then in each iteration, we create one service, one instance of our service using the NCS command to invoke NSO northbound, and then we put the job into the background using the ampersand here. So in this way, things are done concurrently. And it's important that now when we deploy instances of this service, that we don't batch multiple instances into the same transaction, because if we do this, we will not get any concurrency. So if you put 5 instances in the same transaction and you invoke and you try to create them, everything will happen sequentially. If you want concurrency, you need to split up your instances in different transactions. So that's what I'm doing here. And then just quickly want to mention the last thing that we do down here. I've implemented a small sanity check so like once we have deployed our instances, I just double check that the NetSim devices that we actually created all have unique ports. Sorry. Okay, nice. Now we are ready to run. So the way that we run it is that we're going to do it like this. And I'm going to run it. And hopefully, whoops. Right, we tried to run things concurrently, but we did not do very well. We got an error. And the reason why we got an error is because we were making addition by none. So what is going on here? Well, let's dig into the logs. And we can see that the reason why we failed, or the reason why we're getting an error, is because we are getting an error on line 46, because we are adding by none. So why is this happening? Let's go back to our code. Let's jump to line 46, right up here. And okay, so the reason why this is happening is because we're using a global class variable, self.port offset, to pass data between our pre-modification callback and our create callback. And this is not something that is thread safe. The reason why this is not thread safe is because all instances belonging to the same Python service, they share the same service callback object. So when you assign to self, so if you if you deploy multiple instances at the same time, they will all, they will actually, they share all of the variables, all of the global class variables. So when things are done concurrently, we're going to, they're going to just write to the same variable here, and they will just override each other. That's not good. And then when the first instance come down here and set port offset to none, you will actually set the port offset to none for all of the instances that are running concurrently. And this leads to that some of them will actually assign none to the local variable port offset, which in turn leads to addition by none down here. Okay, so this is bad. We don't want to use global class variables like this. This is not thread safe. Fortunately, there is an easy solution to this problem. In this case, there is a better way to send data between our different callbacks, and that's by using the service prop list that we can see here. So what we can do is that, so basically, so the prop list is a list where you can save key value pairs, and any value that you save in one callback can be accessed in subsequent callbacks. So this is exactly what we want to do, so this is a perfect fit. So what we do is that we do prop list.append, and then it expects a tuple, and this is the key offset. And then the value has to be a string, so we set string port offset, bam, 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 return prop list. That looks okay, I think, hopefully. And then if we go down to the create callback, so instead of getting the port offset from the global class variable, sorry. Yes, I think that you do. I think that if you don't return it, we will not. It will not be saved.
Because I get it from the input parameter of the method. Isn't it a reference as a question?
This is a good question, and I actually think that when I did this example, I first didn't return it, and then I failed to retrieve it. Well, I couldn't actually, but so. I think that you have to return it, but I cannot say to 100%. If there's somebody in the audience that you need to return it. Okay, you must return it. Okay, good. Sweet. Okay, going back. So prop list. Oops, sorry. And then we just access the first element because we only expect a single element in it. So we can cheat a little bit. And then the second value of the tuple, like that. That should be enough. And if we now go back to our terminal, oops, why is that? And then I'm just going to reload, recompile our code, and then we run it again. And hopefully we shouldn't get the same error. And takes a little bit of time. What is going on? Okay, so we're getting errors, but it's a new error. So, so we're making progress. So this is great. This is, you know, so we fixed one, and we will move on with the next one. Okay, so now we're getting the error that is occurring, or the reason for the error is because this shell command that we're executing, it returns a non-zero exit status. And we can, again, jump into our terminal, or we can jump into the log file to get try to find out what's going on. And we can see here the error message. So the reason for this error, or the reason why we get a non-zero exit status, is because we're trying to create a netsim device. We're trying to save a netsim device to a netsim directory that already exists, which shouldn't be the case. It shouldn't exist before we try to create it. Okay, so in order to understand what is going on here, it is very useful to understand that we are getting conflicts in our code. So we're getting conflicts on the netsim, or well, the port offset variable, which makes sense because it is like a leaf. I mean, it's data that all of our service instances are accessing, and it's both reads and writes. So yeah, it makes sense that we're getting a conflict here. And if you remember from the slides, if we're getting a conflict in our user service code, then the code would run more than once. Well, in two times in this case. And our code, as it is right now, is not really handling this very, very nicely, because we have a side effect in our code. And the side effect is this one. So we're executing a shell command that actually, that creates a device on disk. And so what is happening is that first we try to, create our instances concurrently, and we'll try to run the service code. And in this time, we will create the device on disk, but then we get a conflict, and then now we need to run the service code again. But then when we come down to this line, then we try to create the device, but it already exists because we created it when we ran the service code the first time. And that's why we're getting an error. So this is also not a good idea. We don't want. It's not a good idea to put service side effects like this in our create code, because things might run more than once. So fortunately, there is a place to put side effects and be guaranteed that it will only run a single time, regardless if we get conflicts or not. And this place is in post actions. Unfortunately, post actions are only available for nano services. So in order to use them, we're going to have to start using a nano service. So that's what we're going to do next. There's quite a little bit more typing this time. So instead of typing, I'm just going to load a new version of the code, version 2. And then we can quickly jump back to our young module. And now we can see that it's the same service, more or less, but now it's a nano service instead. But it functions exactly the same way as before. And then we've also defined an action, which is what we're going to, it's going to be our post action, and this is where we want to put all of our side effects. And just if you go down here, I have defined the plan of the nano service. This is something that we have to do. I have defined the mandatory self component type that has the two mandatory states, the init and ready state. And then on the init state, I have attached our create callback and post action. And then down here, we can just quickly have a look at the behavior tree. It's also nothing fancy. I'm just creating a single component of type self. Right. Let's head over to our Python callback module again. And the only thing that has changed here, well, there's a few things that has changed, but instead of, previously, if you remember, we deployed our netsim device inside of the create callback. Now we don't do that anymore. We have moved that part of the our service code to our post action down here. And one of the nice things about using the prop list is that we can also access it from post actions. Like we do here, we can pull it out from our input parameters. You see we get the prop list, and then we can just get our device name and our port offset. Oh yeah, I forgot to tell you that I'm actually, this is also a thing that I've changed now. I mean, I'm appending the device name to the prop list here in the create callback so we can access it down here. But then I just deploy the NetSim device exactly in the same way as we did previously, but now from a post action instead. So let's run this and see what happens. Okay, so this time we didn't get any errors, and our sanity check, the sanity check that I've implemented also passed. We did create 5 devices in the end, and they all got unique ports. So that's great. So now we are handling retries better, and we are also thread safe. But we are still getting conflicts in our code, as you can see here. And the conflicts is preventing NSO from actually running our services concurrently. I mean, it will try. I mean, it will try to run concurrently, and then it realizes, okay, we have conflicts, and then it will fall back on scheduling the services concurrently. No, it would fall back and schedule them sequentially, sorry. And we can see that it takes roughly 5.6 seconds to deploy our 5 services, and we'd like to improve upon that. So, and the reason why we're getting the conflicts is because we have, because we are reading and writing shared data, which in our case is the port offset leaf. And well, maybe there is a better way to calculate a unique port for each instance that doesn't require reading and writing of shared data. But I'm going to now continue on the premise that this is actually something we have to do in order to implement this functionality that we want. And instead of trying to remove the shared data, I'm just going to try to remove the impact of the conflict, because right now the impact is quite high. I mean, we're getting a conflict, and that prevents NSO from scheduling the service concurrently. So an idea that I have is to try to read and write the shared data in a separate transaction, which will be much smaller and much cheaper to retry. And also, if we get conflicts in this little separate transaction, and if we handle it correctly, then it will not. Yeah, it should be. We might be able to get a better throughput and be able to schedule our service concurrently. So I'm going to load the next version of the code, because I don't want to type this, because I don't want to make any mistakes now. And we can see, so basically the only thing that has changed in this version of the code is that so instead of reading and writing our shared data in the same transaction as the service, we are opening up a new transaction towards the operational database, as you can see here, and then we're doing the shared read and writes inside of this transaction. And let's try to go back here, and let's try to run this and see what happens. So it takes quite a bit of time, so something fishy is going on. We didn't get any errors. Well, we didn't get any errors from NSO, but our sanity check failed. The NetSim devices that we created they all didn't have unique ports. So we are broken something here. And And something that is important to know to understand what is happening here is that we're not running any conflict detection on transactions towards the operational database. And so now we have introduced a race condition in our code. So we want conflict detection on this because we need it for correction. And if we get conflict, what we would like to do is we would just like to apply, like, to read the data again and write the data, and hopefully the next time we write it, or the second time, we will not get into conflicts. Or we will be able to read it without getting any read-write conflicts. So in order to get conflicts, we need to get conflict detection, sorry, we don't want conflicts, but we are going to have to run the transaction towards the running data store. Let's recompile, oops, like that. Okay, and we are getting conflicts, as you can see. We are getting conflicts on the port offset leaf, and but we're currently not handling. So we are getting conflicts, which actually leads to our service code to generate an error, but we're not handling it the way that we want to. So this. It's important also to realize that this conflict occurs in the work phase of the transaction, and the work phase of the transaction is basically everything that you do before you commit your transaction. So in this case, basically these lines, because down here we commit it. And if you get a transaction in the work phase of your transaction, we do not automatically try to, retry the transaction. If you want your transaction to be retried, you have to implement that logic yourself. So that's what we're going to do next. Luckily, there is a new abstraction in NSO 6.0 that is called run with retry that makes it possible to easily implement your own retry logic in both Python and Java. So I'm just going to load a new version of the code where I have started to use. Oops, sorry for that. Mappy run with retry. And this function expects as first argument a lambda function where the first argument is a transaction handle, and then inside of the lambda function you do all of your reads and writes. And if you get a conflict, then the run with retry will open a new transaction and try to apply that one, and hopefully then the second time you will be able to commit your transactions without conflicts. And then here the second parameter is here you can specify the number of times you want to try before giving up. So as you can see here, if you go down, get an increment port offset, this is where we are. This is where we read the port offset and where we write the new value. One thing to be aware of is that this lambda function has to return a Boolean value. So if you want to return any other value, you have to do it by reference. I think I'm not the best Python developer, so maybe there's a smarter way to do this, but the way that I solve this is to pass in a reference here, port offset, and the reference, I mean, it's a list that we pass by reference. And then we just assign the port offset to the first element of this list. And in this way, we can return the value back to the calling function. And then we can just, we can assign the local variable port offset from the first element of the list, like that. And if we try to run this, we can see, oops, I'm just going to clear. That now we are running without errors again, and we're also, our sanity check passes. We deployed 5 devices with unique ports, and we were able to do it in half the time of what we previously did. So before it took like 5.6, well, actually a little bit faster than half the time. So now it took 2.6 seconds to deploy 5 devices, or 5 service instances. So we have done a pretty big improvement. So, yeah, with this I will actually conclude the demo. This is what I had planned to show. Just a quick recap. We started with a service that, it had problems handling concurrent execution because it wasn't thread safe. It didn't handle retries very well because we had a side effect. We were writing the NCS netsim device to disk in a crate callback, which caused us trouble. And it was also and was also conflicting with itself that prevented NSO from running the service concurrently. But we made it thread safe. We moved side effects to post actions, and we managed to limit the impact of reading and writing shared data by moving these pieces into a separate transaction. And the final result is a service that is better suited to run on NSO 6.x. And oh yes, I also wanted to say before I stop, we have some, if you would like to know more, there is some great new resources. There is a new example under examples.ncs, which is very nice, that you should have a look at if you're interested. And then we also have a new chapter in the NSO development guide that is called NCS concurrency model. This code? No, it is not available somewhere, but we could maybe sort something out. Cool.
Wasn't that error at the very beginning, assigning something to self?
Can we just maybe get the mic up so we...
Repeat the question.
Thank you. There was an error at the very beginning that you mentioned that you will explain later.
Right, exactly. So the error or the alarm that we saw in the beginning, right? That's what you're talking. Yes. So yes, so that was NSO that just. So it wasn't actually an error that occurred, but it was just that NSO they realized that we were doing something dangerous in our code, and it was warning us. It was an alarm saying that, assigning to self is not thread safe. And that was exactly the thing that we were doing in the beginning in the example service. That was the first issue that we fixed. If you remember, we were using a global class variable in Python, which was, so if you assign something to self in a Python class, then that is a global class variable. And that's what we were using to transfer data between our callback modules. And yes, that is not safe in a Python service in NSO because these global class variables are shared between all service instances of your service. So if you run things concurrently, they might, modify and overwrite each other's variables or data.
Question. What if you use the threading library to make it safe? Does that still react to that? I mean, you can do thread local storage, for example.
Unfortunately, I am not. Oh, sorry, I cannot see you because of that. I am not very good at Python development, but I would say so. So I'm not sure if I could answer your question. But if you follow basically basic, assigning to self doesn't have to be, a problem if you're doing it in a thread-safe way. I mean, for instance, like if you're using, like a thread-safe data structure or something like that, then.
That's exactly the example. There's a thread local storage in like threading.thread, which is what the services seem to be based on. They inherit that class.
If that is a thread-safe data structure, then I think that shouldn't be a problem.
Is there a guarantee that the daemon thread will be running in the maintained thread?
Is there a guarantee that both of callbacks will be running in the same Python thread?
That is also a good question that I am not sure of the answer to. Maybe is Klaus in the audience? Maybe. If not, I will find out the answer for you. I'm not. This part is not something that I'm 100% about. So I'm couldn't give you an answer right now. But I will find an answer for you, and I will grab you afterwards.
Any more questions? Anybody? Yeah, there's a brave one. Thank you.
Quick question, not really technical. So just to confirm on the documentation, we should now find some kind of concurrency documentation and maybe some kind of like best practices and, I don't know, some common pitfalls or something like that?
In the documentation right now?
Yeah, on that link, I guess. On the development guide.
I guess it depends on what you mean with like common.
Oh, like best.
I mean, there is no like coding examples. I think it's more like that you should, your data accesses need to be thread safe, and like you shouldn't have. You need to be idempotent and
okay,
so like more.
More generic
level recommendations. I don't think that there is anything that is
not NSO specific, let's say.
Specific.
Okay, got it. Thank you.
I'm just curious, what's the time difference between your first code and the last one? Because you do optimization.
Yeah, exactly. Well, actually, the time it took to deploy 5 instances, like in the first version, where we could actually do it without getting errors. Then we could do it when everything was just running sequentially. It was 5.6 seconds or something like that. In the last version of the code, it took 2.6 seconds. But something that is important to know here that we still have like deploying and creating a NetSim device and starting a NetSim device. That is a kind of quite heavy actually on my computer. So if you do, because starting a NetSim device, that's actually starting a conf device, and if you do. So that's like a sequential operation that is it takes a little bit of time. And if you have this, if we would have had something that...
So just to follow up, did you try it with the 5.x? And if it, the base sample, how the performance differs? We do bad, like NSO is forced to do assumptions that doesn't work. Does that end up being slower because it's retrying, or is it still faster because it's trying to do it in parallel? But if you don't know, that's fine. I'm just curious.
I think that it could be. I'm not sure exactly because I haven't tried it, but it. Since we are doing the retries, then that could potentially do it marginally. Slower.
I think we have time for one last question here. There we go.
I'll try to make it quick. Just wondering, that one thing where if you create a transaction and then there's some conflict and then it just fails, it seems like the kind of thing that people aren't super familiar with this would do quite a bit. So I'm wondering if there's some plan to give a warning, just like you do for when you're using a global variable.
You mean like if we would like to give you like a warning
like
if you're
there's no retry on this, or because it's the kind of thing that would be, you could very easily see a beginning coder would code this up. It works perfectly fine whenever you're doing one at a time, but as soon as you go concurrent, which may not be in their test scenario, but it could be in their production scenario, you start seeing problems.
I'm not aware of that there is a plan to raise a warning in this situation, but it might be a good idea, I guess. And maybe something that we could. Maybe you can add it as a gestured feature.
Services are
Yes, that's correct. Yeah. So it's.
All right. Love the conversation, but we have to time out here. Thank you very much, Jakob.
Yeah, I will be around for the next couple of days, so if somebody wants to.
Yeah, please hook him in the break or whatever, and keep asking the questions. It's a big round of applause for Jakob.